Alright, in this video, we are going to look at how to find the impulse on an object when the object falls from a height and rebounds to another vertical height. Here, we are going to look at this using this simple problem on the board. A ball of mass 200 grams released from a height of 2.0 meters hits a horizontal floor and rebounds to a height of 1.8 meters. Calculate the impulse received by the floor. They were asked to take the value of acceleration due to gravity as 10 meters per second squared. So what we simply have to do is to quickly write out the parameters. So the mass M is 200 grams. That will give us 200 divided by 1000, since I am going to convert this to kilogram. That gives me 0.2 kilogram. Then I have the height in which it fell from, h1, as 2.0 meters, and I also have the height which it rebounded to as h2, which is equal to 1.8 meters. Then the acceleration due to gravity is equal to 10 meters per second squared. So these are the parameters that are required. So what I'm going to do is to draw a diagram, assuming this is my horizontal level ground and the ball is dropped from a height here. So this is the ball. It's dropped from a height h1 equals 2.0 meters. Now when the object, the initial velocity of this ball, let me call it u1, is equal to 0. And the final velocity of the ball, let me call this v1, is unknown. Then when the ball hits the floor, it rebounds up to a height. So I'm going to give this a height, h2. Okay, let me use this way. h2 equals 1.8 meters as given from the data. So this is the height. h2, 1.8 meter. Now, as the object hits the floor, it impacted on the floor for a very short period of time. So that impact, due to that short period of time, gives the impulse on the floor. So it means that the object is going to move up with a velocity that is slightly less than the final velocity when the object impacts on the floor. So I'm going to call this U1, U2, and that is unknown. Then here, when the object goes up, it's going to have a final velocity. Let me call this V2, which is equal to 0 at this maximum height. Now you can see that I have described the motion of going down as motion 1. So I'm using U1 and V1 for the initial and final velocity. And I'm driving the upward motion, I'm describing as the second motion. So I'm using U2 and V2 for the initial and final velocity of the upward motion. So what we are going to do is to calculate the final velocity when the object reaches the ground, when it reaches the floor. So I'm going to use the velocity formula for motion under gravity. So I have V1, let me do this, just close this. V1 squared equals U1 squared plus 2GH. I'm using plus because the object accelerates as it goes down. So V1 here, the initial velocity is 0, so this is 0. So I have V1 squared equals 2 times 10, acceleration due to gravity, times the height. Times the height, which is 2 also. So V1 squared equals, when you multiply this together, you're going to have 40. And V1 is equal to square root of 40. That will give me 6.32 meters per second to two significant figures. Now again, I'm going to look for U2. So I'm applying the same formula, but in a different. So I'm going to have V2 squared. The final velocity square is going to be the square of the initial velocity minus. Now I'm using minus because the velocity what? Reduces. It decelerates. Minus 2GH2. So this is H1. So I'm going to have this. This is 0 at this point. 0 equals U2 squared minus 2 times 10 times the height is 1.8. So I'm going to have this 0 equals U2 squared minus 2 times 10 times 1.8. That gives me 36. So when I bring this, I'm going to have U2 squared equals 36. And U2 is equal to square root of 36. U2 equals 6 meters per second. Now you can see that there is a slight difference between this and this. Now the next thing we have to look for now is to look for the impulse. Now from Newton's second law of motion, we know that F equals change in momentum m1 mv minus mu. Initial velocity in final velocity minus initial velocity. These are the momentum divided by time. So from here, when I cross multiply, I'm going to have Ft equals m into v minus u, or mv minus mu. Now in this case, this is the impulse. So the impulse is equal to what? mv minus mu minus mu. So impulse is change in momentum. So that's the impulse. Now we can calculate the change in momentum. So I'm going to calculate mp1 is equal to m1 v1 this. So that gives us what? The mass from our given parameters. The mass is 0.2 times v1 6.32. So that gives us 0.2 times 6.32. That gives us 1.264. 1.264 Newton seconds. That's the unit for change in momentum or impulse. Then again, I'm going to calculate P2. So that's going to give us what? MU2. Because this is where at the base of the floor, or on top of the floor, that is where the change in momentum took place. So that's going to give us what? Now I'm going to assign one of these to be negative. Now because they were in different direction, this was going downward, so I'll take this to be positive, and this was going upward, so I'm going to take this to be negative. So I'm going to say minus MU2. So that's going to give us 0.2 or minus 0.2 times 6. And that will give us 1.2 minus 1.2 Newton seconds. Now remember that our impulse I is going to be equal to change in momentum. So I'm going to have mv1 minus mu2. Or rather, let me just leave it at this, minus mu2. That is the change in momentum. So I'll just apply all the values here. So the impulse I equals mv1 is 1.264 Newton seconds minus mu2 is what? Minus 1.2. Minus 1.2. So that gives us I equals 1.264. Minus times minus is plus 1.2. So I equals 1.464. We'll just approximate this to 1.46 Newton seconds. So that is the impulse received by the floor at the point of what? Impact.